We're live.
All right. Hello, everybody, and welcome to Energility, Connecting the Dots, our monthly webinar series focused on all things related to energy, energy efficiency, energy conservation, renewable energy. Past couple of months, we've spent a lot of time speaking to you about PACE or C-PACE financing and creative ways to um, park or take care of the financing on your energy efficient projects for your building. But today, since we always get asked about how do you do the things that you do, today's going to focus on the tools of the trade and some of the things that we use to do that. And, Justin, it seems like forever this is one of those webinars topics that we've wanted to get to. It's good to finally get to this one.
Yeah.
So, Richard at Energility, Justin at Energility, we'd love to hear from you if there's any topics you want us to hit on, either today or in future webinars. Please feel free to shoot us a message. We'd love to hear from you. But in the meantime, Justin Kale, Director of Opportunity Development here at Energility, take it away. It's all you. There you go.
Thanks, Rich.
Sure.
Yeah, we'll go over some of the tools and we'll talk about some of the data. And at the end of the day, like you said, we get asked about what it is how it is we do what we do,
Mm-hmm.
because folks see a report or they you know have a conversation with us and they're like, oh, that's interesting, or have that aha moment. And how do we connect the dots behind the scenes doing what we do? Well, one of the first things that we would start with is, maybe somewhat obviously, is looking at a utility bill when we're talking about energy. And, there's, a few different things on there in terms of the cost and the usage. And, at the end of the day, most folks talk in dollars and cents. Um, and this is what most folks see when they deal with energy. And one of the things that we do a little differently is we start to think about, what's the load profile? What is the building's operational characteristics that we can pick apart to understand how they're using energy? Maybe a little bit obvious on the utility bill that, oh, they're using a lot during the wintertime. Great, they have a lot of energy use for heating. Well, but if they also use gas to do domestic hot water or cooking, how do we know how much is proportionate share of gas going to those pieces of equipment to know, do I upgrade my stove or do I upgrade my boiler? And if so, if it's both, which one do I do first? This kind of gets into the a little bit of the science of taking the data and then picking apart the energy use based on weather use, and different times of the year, whether it's on all the time or whether it's on part of the time. And so, we start to use some software tools. One of the more basic tools out there is Energy Star's Portfolio Manager. It's a tool that gives very few data inputs, things like the building's size, the address, maybe how many people are in the building, how big the kitchen area is, maybe specific characteristics related to that building type. For example, a house of worship, one of the defining characteristics is how big is the worship space, versus an office building that wants to know how many people, how many computers, how much of it is air conditioned, things that are going to be factors in performance of the building. And so that uses a few basic data points, actual energy use, and then gives a score that's a 1 to 100 score. And it's really also used in not just being able to look at an individual building, but communities use it for benchmarking. Columbus here about 5 years ago, 6 years ago, got a benchmarking ordinance where they require buildings of a certain size to actually submit the energy data, and then it's used in comparison to what's happening in the community as Columbus has adopted a climate action plan. What are the things that they are doing at the city, but then also encouraging the residents and the businesses to do as well. And this is a kind of a scorecard tool.
So it's a way to move from just an absolute score to a relative score to see how you're ranking
Great.
compared to peers.
You always have some good insights in connecting the dots. That's exactly one of them. Is how do how do you tell how you are in your competitive set?
Mm-hmm.
Business is a little bit of competition as well, right?
Absolutely.
So when we get hired to come in and walk a building and make some observations, sometimes we're making those based on our experience, but then other times we're getting into, and as we get deeper into more progressive levels of energy audit, uh, we're starting to use some tools to give us additional data, not just what's on the utility bill, but hey, what's behind the walls? What's how much insulation is there? What's above the ceiling? How can we look at the outside of the building and tell, is there actually any heat coming out? I don't know if you've ever walked through. I know you probably have in some of the buildings we've walked through, but we were just walking a building the other day, and as we opened the door, there was a big burst of air. Well, it turned out after talking with them for a few minutes, and we were familiar with this building because we'd been there before and we're helping design a project. But one of the things that they know they have a problem with is they have an old control system. When we walked in that one door, it was very clear that they're putting a lot of outside air in that space and it was pushing air out. It was actually a house of worship that the organist was in practicing. They're about a 10,000 square foot sanctuary in a 50,000 square foot building. So roughly 25% of the building was being air conditioned just for, the organ practice, which again, could be the right thing to do, but it just showcases a characteristic that, making that observation when you're walking through the door, it starts
That's right.
leading to some conclusions about what's happening. And sometimes we need data loggers like what you see here, um, something to collect temperature and humidity, track the occupancy trends of a space. That gives us more and more data. And we'll talk about here in a minute. Not all data is best, right? Some's good, more is better. How much is too much? We don't want to get the old analysis paralysis. But when we start, we don't exactly all have X-ray vision, and the infrared camera gives us the best ability to be able to take a very basic, simple concrete wall and be able to see, hey, maybe there's some an insulation impairment, or maybe there's a connection where there's some what they call thermal bridging, and some things you can't do anything about, but you can make a um, knowledgeable choice or awareness about a situation. Or, in this case, you can see there's a little bit of heat coming out around the foundation. Again, they're probably not going to pick this building up and put, insulation around the foundation, but, it's also just something to be aware of that could be causing a drafty spot on the inside of the building where there's a lot of heat lost to the building envelope. So, as we get more and more data, some of those data loggers will give us, like that thermal camera will give us an instantaneous point. What's our reference to a given point, and it'll tell us what that temperature difference is, so we can, make a calculation of what the building insulation and the building envelope is doing. But some of those data loggers, like the one we just looked at a few minutes ago, that tracks temperatures and humidities and lighting and occupancy. Some of those data loggers and can get down to minutes. Every minute it's giving you a piece of data, or you can program it to say, oh, they want it every 5 minutes or 15 minutes. And in some cases, getting it every minute, gets so granular that the data becomes really unclear, or it becomes a little bit of noise in so much as the building system's not reacting every minute, but we're getting a minute of data,
Right.
for days or weeks, and that can become a lot to sort through. So again, not a lot of data is good, but not all data is equal. But it does allow us to get more data points than just the utility meter. And one kind of tip that you have for not only your building but your home as well is most buildings, especially in central Ohio and many areas around the state of Ohio and around the country, have moved to smart meters. And those smart meters give the utility access to data, at the interval level. In most cases, it's about a 15-minute interval. That's actually something my wife and I looked at ours recently and identified some trends where we're like, oh, this is when we're having coffee in the morning, and this is when she's doing some laundry and she works from home. So, there's some static or some base load during the daytime
Mhm.
that you might not otherwise exist if we're both gone. And you can see when we go to bed at night, or when somebody takes a shower during the day, you can see some of those upticks in energy use. And that interval data is very helpful for identifying some trends. And that's, one of the reasons that we use these tools is not just to be able to see what's going on at the, 12 times a year when the utility reads the meter, but what's happening day over day, week over week, maybe month over month. And those intervals can give us some data. We'll go through that here in a minute that can help us kind of, we tell folks all the time, right? We try to split the atom, and we're
Right.
not exactly rocket scientists, but we're pulling some data trends together that are giving us some insights, and then allowing us to be able to make some informed recommendations. So a couple of the places that we focus when we're doing an energy audit is, you know, walking around the building, seeing the building envelope gives us a big picture look. But once we go inside, in some cases we're doing things very much on an observatory level,
Mhm.
when we're doing a level one audit. But then we get into a level two audit and we're starting to unpack things and starting to get into those load profiles and, get back to that, second or third slide with, getting a lot more detail about the individual systems. One of the ways we can get there without spending weeks upon weeks at a building is being able to interview the facilities folks and understand, what's happening at the building. But then with data, we can start focusing on, hey, let's look at the gym, let's look at the, big conference areas, let's look at the areas where people are moving about in more transient fashion. Let's look at some of the office spaces that, if I said, hey, Rich, show me the office that's just like every other one, or show me the wing of classrooms that's just like the others, what are those areas that are repeatable? Those are the things that we're getting into, observing, and that helps us again build some trends, build some knowledge about what's happening in the building. And then, once we've kind of assembled all of these different data points, individual spot readings like the infrared scan, and we get a couple days or a couple weeks worth of interval data. We have the utility bills. We can start to put it together and, again, build out some trends. And almost let the data tell the story, right?
That's right.
It's not like the data is doing the audit for us, but certainly as we're building the energy plan with our experience, we're taking a look at, this graphic of data and going, okay, is this a reasonable profile? Why was there a spike up here? In this particular month would have been, looks like that was sometime around 10, 11. So that'd be like an October spike up and then a very big drop off. You know, was that actually something really intense happened in October? Or was that this was an estimated reading and this is an actual reading? And really it was more of a softer curve there. Again, the data pictorially, tells something that allows us to be able to ask the question, what's happening here? And is that something that's we're going to make a recommendation on, or is that just a data anomaly?
Sure.
So I always say that, and I guess maybe I'm inferring that everybody likes Excel as much as we do, but being able to throw numbers in Excel, you can build some pretty simple, but also some complex graphics. And we also use some other software tools, and this is one that gets into what we call a multi-point regression, and that's really just engineering nerd speak for we're taking the utility data at the meter, and it could be additional data points, but typically we're taking it at the meter and saying, let's graph that compared to the weather trend. And based on, it getting warmer or getting colder, what's this utility meter look like? And in this case, it looks like there's an obvious inflection point here in the 60 to 65-degree range, and there's more energy being used here as it gets colder. This happens to be electric kilowatt hours per day. And this is probably from a cooling system. And that may be even obvious when you looked at the utility meter, but one of the things that we can start to identify here is how many kilowatt hours are using every single day of every single month of every single year, regardless of weather. Well, in order to really understand that, that's where we need to understand what's happening in the facility and collect nameplate data off of the heating and cooling equipment, fans, pumps, count the lights, etc. But there's a lot of energy being used here all the time. In this particular case, we're looking at this same type of weather trend compared to, in this case, it's gas, but we're looking at simply two different time periods, and there's a different inflection point here. That could indicate they made an update to a control system, could indicate they had a failure of a piece of equipment or a degradation of outside air damper, maybe not getting as much outside air or getting more outside air than before. And also the lines went up a little bit, so that also could indicate they're using a little bit more gas on a day over day, month over month basis from cooking or hot water, um, hand washing, potable hot water. And then, we go beyond just, hey, a utility graph month over month, but, you know, trying to correlate it to weather. Now we start looking at, you know, the different days that we put a data logger in place, and we start looking at the relative humidity compared to temperature. This one has a little bit of fluctuation day over day, hour over hour, but there's big fluctuations here in relative humidity. Those could be, time periods in which the building was occupied versus unoccupied. It might have been a big change in outside weather. We do live in the state of Ohio, so
Right.
we had some snow on the ground actually today. Whenever you're watching this was recorded in April. We did have some snow on the ground earlier today, um, and it'll change. We might have summer by the end of the week. Um, but these could give us some data points that help make a decision, or again, ask the question, hey, is there something going on with the way the building envelope is controlled, the dock doors, the way the windows either operate or don't operate, or the outside air or makeup air unit. Just had an interesting conversation earlier today about a continuing trend in seeing the outside air equipment in buildings that isn't functioning correctly. And sometimes it's broke and it needs to function, and other times it's broke in so much as it's stuck on and it's pouring a lot of outside air in. But that's a common piece of equipment that seems to be either there's a weird trend there in the industry or just something that we've stumbled across here recently. And this one here is a good example of, there's a few temperature variations, but there's largely a flat line here. And when you zoom in, and I will admit we'll reimburse you for a set of reading glasses if you have to zoom in too much there with your eyeballs. But you can see there's only a little bit of a degree or two of deviation there on temperature. This is a good indicator that there, the thermostat that's controlling this area or the sensor that's controlling this area really isn't doing anything other than it's locked in on a single set point, you know, seven days a week, 24 hours a day. And again, that's something that we wouldn't necessarily see, because if we walked up to the thermostat, we may see, oh gosh, it's set at 72. We don't know, are they really manually turning that down at night? Or are they, is there a schedule working on that thermostat? This gives us the data to show us what's really happening there. This is another, just another quick graphic from one of our data loggers that just shows CO2 readings. And CO2, as we're sitting here, Rich isn't giving off too much. I'm giving off a lot by sitting here yakking.
Just a typical day.
Another day at the office, right? And this is what it would look like if we were graphing Justin's talking versus Rich's talking, right? Um, but in all seriousness, this is a set of data points that when we put this logger in a place, whether it's a gymnasium, whether it's a conference room or an office, we can see upticks in CO2, and that is simply something we give off every time we talk, every time we're breathing. And so we can see, hey, is this a densely occupied space? Is it occupied a lot? Is it occupied infrequently? And if it is occupied, does that line up with how the outside air system is operating for the building? And should it be, putting more outside air in, or is there, is it pretty flat? And also, we know that the space was occupied and it's just dumping 100% outside air in so that it's compensating for the people in there, but it's also probably costing them a fortune to run that system if it's giving 100% ventilation all the time. So again, more data and more good data to help us make a decision. That's what this is all about. Listening and observing, and then also reflecting and making observations in the data. Some of our lighting graphs that we are able to capture data on, show us, what happens when somebody's in the space versus the lighting. And if somebody comes in the space, turns the lights on, turns the lights off when they leave, probably not a lot of opportunity for sensors and sophisticated controls. But somebody comes in, turns the lights on, and they're on continuously. Most buildings, even ones that are really considered 24/7 or continuously operating buildings, most of them do have some areas where there's transient occupancy, like conference rooms or restrooms or maybe some different hallways. And so we want to not just broadly make that recommendation that, hey, you should put lighting controls in. It's probably a good idea, but the data will help us not just determine is that a good idea, but it'll help us quantify it. And another way we can visually see that a little bit better is being able to see, hey, here the lights are on and unoccupied, or I'm sorry, off and unoccupied, which is what we would expect, and then they're on and unoccupied a little bit of the time. Again, is that the right amount? I don't know, but it gives us data that we can make that calculation and say, hey, if we're going to put lighting controls in here, we're going to make that recommendation. We have some data that gives us a case of what the lighting profile looks like.
Which piece of the pie chart is our opportunity to find improvement?
Yeah, so looking at, let's see, so we got green here that's on and unoccupied. So basically, hey, there's an opportunity there. And this one's only about 8%. And in the red, it's off and unoccupied, 71% of the time. And there's some varying conditions, right? Are they off and unoccupied? Or I'm sorry, are they off and occupied? I've been in buildings where you have a meeting with somebody, their office or their desk is close to the windows and they don't turn the lights on. Uh, but this would give us the kind of the, green would be our opportunity, red would be, hey, they're doing it correctly. There's no opportunity
Right there.
yeah. And in this case, about 3/4 of the time they're doing what they're supposed to, turn the lights off when nobody's in the space.
Mhm. And
Good,
they need to
good
hear good
question.
news too, right? And what they're doing right. Somebody that's coming in for a study.
Yeah. That's a good point too, because again, talking about getting more and more data,
Mhm.
sometimes we come across things where we're like, hey, this is what we would expect to see. We can feed that back in a report and not just go, hey, here's all the bad things you're doing, and here's all the shiny new toys you should save up money for that you should plan to buy. Hey, here's some good things that you're doing, and also some data to support that, not just, you know, Justin thought it was a good idea, or hey,
Right.
Rich thinks it's a good idea.
Coming from the banking world, audit sometimes has a negative connotation, and it's not always that case.
Yeah, good point. So when we were talking about interval data a few minutes ago, one of the things we can do is kind of slice and dice that interval data in those granular increments to say, well, how much energy is being used um, on Mondays, Tuesdays, Wednesdays, days of the week. This is data from a manufacturing audit we recently did. And this again goes back to we're trying to learn and observe things from talking with our client, but then also synthesizing that with data. And this reflects what they told us. They're using less energy during the weekends because they have 5 shifts that run around the clock, and then they have one shift on the weekends.
Mhm.
Well, this kind of speaks to that, right? But it also does quantify it for us too, and we can see visibly here that clearly their shift does end around 8 o'clock, which is uh, correlates with what they told us. And then I believe this is Sunday here. Sure, arrows not over top, but yeah, and so then they're starting up here on Sunday, getting up to speed, at the end of the day.
Mhm.
So, again, this separates it out, but then we can see on a kW or kilowatt basis, we can see what that load looks like per shift. But then the other thing that's really interesting is they're always running at least 250 kW down here. And that's kind of startling because, that's, dozens and dozens of houses of energy that are being used day over day, hour over hour, regardless. And so in some cases, we've seen this happen either whether it's on a building level basis or a system level basis where somebody says, hey, I'm shutting the equipment down, but we still see a base load or a continuous load here, and then we can quantify that. In this case, let's look at that for a second because we'll show you another example of that here in a minute. But this is simply taking, month over month and saying, okay, over the course of a day for every single month, what does their load profile look like? And you can see it's pretty darn consistent in through here. A little bit of a drop off here around the 3 o'clock time frame, and
Mhm.
a little bit of an uptick here later in the day when they have a little crossover between the second and third shift. Again, more data that helps either substantiate, something we were told or observed, or is able to give us, you know, a recommendation. And that's where we go here when we were talking about that previous slide just a minute or two ago, where they're continuously using 250 kW every day, every hour. We got really deep in that for a month period of time and looked at, when is that happening? And so there looks like they have a drop off here at some point, and this is over the weekend, which again kind of gives us a second set of visibility into that uh, interval data to substantiate, hey, there's 250 kW that they're never getting to zero.
Right.
So if viewing the data one way, you may be concerned that, oh, is there an anomaly there, or is there a trend that maybe I'm reading too much into the data? This is just another way to slice the data, and the pie tastes the same. So again, we do this type of work to listen to our clients and observe and understand what's going on in the building, and then be able to take that, what to some folks is a complicated utility bill with a few data points on it, and we see it a little. We correlate it to energy use, weather, and then also different system uses, and that's what we see. And so when we connect the dots, part of what we're doing with an energy audit, and what should be done, whether you hire us or you hire somebody else, is being able to study the building with a level of expertise and a level of building knowledge and intelligence, but then take it a step farther than just saying, hey, these are good ideas or these are best practices. I had somebody that I was reading one of their articles recently that I respected, and I thought it was an interesting statement that you shouldn't always be going for best practices, because if you want to be better than the best, and you want to be top of the class, everybody's trying for best practice. So what are those things that separate your your practices?
Mhm.
And using tools to obtain data helps make informed decisions. And again, not all data is created equal, so we want to make sure we're using the right data and looking at it from the correct lens, which comes with some level of building intelligence, but then also listening to what folks have to say about their buildings. They're the folks that are living and breathing in this building day in and day out. If we can use data to help connect those dots, that builds some of those aha moments.
That's the hands-on data versus the measured. uh, numeric data that we obtain.
Right. So that's what we do, connecting the dots, building the energy plan. You want to wrap us up, Rich?
Sure. So, great topic. I hope you all found it of value to you. Have any questions? Justin at Energility, Richard at Energility. We're happy to have a conversation and learn more about what you're experiencing and what you're thinking. Uh, Next month, please join us on April 17th. The topic is going to be the top 10 best findings from an energy audit. So it's taking what we talked about today and what are some of the things that you can expect or hope to find if we do an audit at your facility. You're not going to want to miss it. It's going to be a good one. Thank you very much for sharing your time with us today, and we will see you next month, and keep on conserving because every watt counts. Take care. Good job.
Yeah, nice job. You too.